Hi everyone, I'm Aishat Nafia from AML department. My topic is about unveiling the secrets of image detection, point, line, and edge. Welcome to the world of computer vision. In this presentation, we will explore techniques for identifying and analyzing key elements in images, including points, lines, and edges. We talk about how computers learn to see and understand images. Computers break down images into smaller parts like points, lines, and edges. These are the building blocks of any picture. For example, the edges in an image can tell us where one object ends and another starts. This is very important for things like recognizing objects, identifying shapes, or understanding how things are placed in an image. Point detection techniques. There are methods in point detection. These techniques aim to isolate individual points of interest within an image where intensity changes drastically. Means point detection is about finding specific spots in an image where the brightness changes a lot, like a sharp corner on or a dot. These points are often the most interesting parts of the image. For example, if you are looking at a photo of a building, point detection will help find the corner of the windows or doors. These points are useful for tasks like counting objects in an image, tracking how objects move in a video, or matching two images by comparing their points. Its application used for tasks like object counting, tracking, and feature matching in various computer vision applications. Now let us go one by one. Line detection techniques. These line detection techniques have Hoff transform edge linking line segmentation. Hoff transform is a powerful algorithm for detecting linear structures in an images. Like a method to find lines even if the image is noisy or blurry. It's commonly used to detect roads or borders. Second one is edge linking. Edge linking is connecting discontinuous line segments based on intensity thresholds. Means if a line is broken into pieces, this method connects them to form a full line. Third one, line segmentation. Identifying and separating individual lines within complex images. Means this separates one line from another, which is useful in images with multiple lines like text or road markings. Edge detection fundamentals. Intensity changes, edges represent boundaries where there is a significant change in image intensity. And it is also a discontinuity because edges mark sudden transition in color, brightness, or texture, indicating boundaries between an objects. And it is used to detect object boundaries like edges provide crucial information about shapes, outlines, and the separation of distinct objects. Means here edges are places in an image where there is a big change in brightness or color. Now think of a photo of a car. Edges are the lines that show the car's shape, like the outline of the roof or wheels. Edges also help us understand where objects start and end. They are the boundaries that separate one object from another, and they provide important details about shapes and textures. Now let us talk about gradient based edge detection. In gradient-based edge detection, we are going to Sobel operator, Prewitt operator, Roberts operator. So, to gradient-based edge detection is to find edges. We look at how quickly the brightness changes in an image, which is called the gradient. This slides explain three methods. Sobel operator. It is a popular method for detecting edges by evaluating intensity gradients. Means it looks at how brightness changes in both horizontal and vertical direction to find edges. In Prewitt operator, similar to Sobel operator but focusing on detecting horizontal and vertical edges. Means uh, similar calculation to detect edges. Next, in robot operators, detects edges by comparing adjacent pixel pairs, emphasizing diagonal edges. Means here it checks changes in diagonal directions, making good making it good for detecting sharp edges. These methods are often used to find clear, strong edges in images, like the boundary of a building against the sky. Laplacian based edge detection. In Laplacian based edge detection, uses a different mathematical approach to find edges, like Laplacian operator second derivative zero crossings. In second derivative, it utilizes the second derivative to find edges. In Laplacian operator, a commonly used operator for Laplacian edge detection, it calculates the second derivative, which means it looks for places where the brightness changes very quickly. And in zero crossings, locating edges by identifying points where the Laplacian crosses zero. Means this method pinpoints the exact location of edges by finding where the brightness shifts from increasing to decreasing. These techniques are useful for detecting thin or detailed edges such as the veins in a leaf. Next, moving on, Canny edge detection algorithm. It is a very popular and reliable edge detection method because it works step by step. To step on noise reduction, smoothing the image to reduce noise and improve edge clarity. Means the image is smoothed to remove unnecessary details like noise, making it easier to find edges. Second step, gradient calculation. Calculating the gradient magnitude and direction along edges. Means to find the strength, calculating the strength and the direction of edges are calculated. This helps in understanding where the edges are and how they flow. Third step, edge tracking. Connecting edge segments based on gradient, direction and thresholding. Means strong edges are kept and weak ones are removed in edge tracking. The algorithm also connects broken edges to make smooth and continuous lines. This method is widely used in things like detecting faces or objects in photos. Thresholding edge and edge linking. Thresholding means filtering out weak edges based on intensity of the threshold. Means this filters weak edges and keeps only the strong ones. For example, in a photo, faint shadows won't be detected, but strong boundaries like the outline of a box will remain. In edge linking, connecting fragmented edge segments based on proximity and intensity similarity. Means this joins small broken pieces of edges into complete lines or curves. It ensures that edges are smooth and connected. Um, these techniques help in tasks like identifying the shape of objects in an image. Applications of edge and line detection. Edge and line detection are crucial for various computer vision tasks. These techniques enable object recognition, shape detection, image segmentation, and more. Edge and line detection are very important in real life applications. Object recognition is to finding objects like cars, faces, or signs in an image. Shape detection, recognizing specific shapes like circles or rectangles for things like traffic sign detection. And in image segmentation, separating an image into parts like dividing the background and foreground in a photo. These methods are used in many fields, including security systems, self-driving cars, and medical imaging. Thank you.